Good afternoon, everybody. Welcome to class today. Thank you for joining me. Today we're continuing on in Module 2 of the course. We're talking about turning data into information. We're just going to have a look at the standard structure of a query today, right? Remember that Module 2 is kind of geared around getting our environments all set up. I've got mine, figured out my issues from last week, got mine all set up now. Got that password problem changed. So, we want to make sure that we have our environment set up and ready to go. So we have, this first module, or this second module now, really, where we're doing that, setting up our environments. So next week, instead of a regular live class, just to make sure everybody has their environment set up, we'll have a sort of a help session during this time, right? Since it's the last, the last Monday before Module 2 is due, Module 2 being due not this Thursday, but next Thursday. We'll have a help session during this time through Teams, just to ensure that everybody has their environment up and running and everything is going well. Also, there is no study hall on Thursday. I sent out an announcement earlier to that effect. The study hall is the 10:30 to 3:30 open lab in room 3200. I will not be here on Thursday. I will be leaving earlier in the morning for a cybersecurity conference in Montreat. So I will be away out of the office the remainder of Thursday and all day on Friday. With that being said, I think we can go ahead and get started talking about what we're going to talk about today. And I think we might end up with a little bit of a shorter class today. Right? Because what I want to do is just talk about a few more things that will end with us playing in our MySQL Workbench databases just a little bit so we can kind of understand what's going on there, right? So, again, like the big goal of this module is to make sure you get your environment up and running, get your, sample data set that we use into our database, and then to just run a query and just see what happens when we run it. So just as a bit of a review from some of the things that we've talked about before, right? We kind of talked about our information cycle, right? And we've said that information is data that has been processed. So we call data raw, right? Like we said that, data is kind of like, when you go to the grocery store, you buy a pack of chicken in the butcher's department, right? You can't really eat that chicken as it is, right? Like there's some inherent value to it. You had to pay for it. It's sitting back there, but on its own, you can't really do much with it, right? Like you can't eat raw chicken. It can make you very sick. But if you take it home and you put it through a process, i.e. cooking it, right? Seasoning it, baking it, or frying it, or however you want to prepare it, then all of a sudden you have something delicious that you can eat for dinner, right? And so we can kind of look at that as information. Information becomes valuable. So data becomes information after it is processed, just like our chicken becomes dinner after it is processed. So in our databases, we have data stored, right? And we've said previously that, the thing about data on a database is that, it's just kind of sitting there. And since it's just kind of sitting there, it doesn't really have any inherent value to it. It's just, ones and zeros sitting on a hard drive waiting for us to do something with it. And so with this, we're kind of saying, okay, well, what do we need to do to make that data valuable? What do we need to do to process that data and turn it into information? And that's going to be kind of especially early on here, that's going to be the majority of what we're doing, right? Is we're going to be writing queries to take that data that's in our database, run it through some sort of process, and give it out to us as information, right? And in terms of information, it's something that has value to us. It's something that we can interpret, right? Our computer's not really interpreting it. Our computer is just kind of giving us or removing data that meets or does not meet a certain set of parameters that we define for it, right? As far as our computer is concerned, nothing in any database means anything. But when we set up some parameters through a query, we get the information processed and brought back to us, and we prescribe the value from that to that data. We tell the story with that data, right? That's something that we're going to be talking about kind of going forward, is not only getting this information through queries to be of value to us, but actually using this data that we've transformed into information as a foundation for helping us make decisions and things of that nature, right? So we've used this word query a time or two, and we've brought up this concept of a query. Just what exactly is a query? So, if we look at the Merriam-Webster dictionary, we can see that a query is a question, especially one addressed to an official or an organization. So the key word here for what we're being purposed with is that it's a question. Right? It's some kind of question, and we're kind of asking a question with parameters. So essentially what we're doing is we're giving our computer a set of parameters, and in doing so, we're asking our computer a question about the data that is stored in our database. Now, in this instance, right, I kind of jumped the gun a little bit here. Who or what are we asking a question? Right, because we said a query is a query, or a query is a question, rather. But is this definition really that good for us, right? Does it really kind of meet the purpose of everything that we're talking about when we're talking about a database query? And so we've already kind of gotten the idea here that when we're making a query, we're asking our computer a question. And so really we're making a request for information from our database. We're asking our computer, hey, I need data that meets these parameters. Can you give me data that meets these parameters? And our computer kind of goes back and it looks through. And it says, okay, yeah, I can do that. I can give you that. And, typically a lot of the times what I'll do is I'll use this sort of analogy of a waiter, right? Somebody who's, waiting tables at a restaurant. You come in, you sit down at their table, and you look at the menu. And we can kind of look at the menu in these sort of instances as our database, right? Like it's a stored bit of data that, right now there is a corresponding, piece of food or whatever in the back that corresponds to every single entry on a menu. At this point, that food in the back, it's, just like the food in our analogy earlier, it's raw, it's uncooked, it needs to be prepared. All right, so you're going to ask your waiter to make a preparation. You're going to say, okay, I'd like, a steak with mashed potatoes and glazed carrots. And the waiter says, okay, I'm going to go back to the kitchen. I'm going to make this request for a steak, mashed potatoes, and glazed carrots. It's going to go through a process. It's going to come back out to you as a prepared dinner. Right, so we're asking our computer or we're asking our database to take, what it has stored back there and turn it into something useful for us based on the question that we give. Now, sometimes we can be more specific with the question we give, just like in my example there. I'm asking my waiter, can I have a steak, mashed potatoes, and glazed carrots? Right, but I can also take that and I can also be even more specific with it. Can I have a steak medium rare, mashed potatoes with butter, and a small portion of glazed carrots? Right, so we can get even more specific with it. Or we could get less specific with our queries. Right, and more general. Because we could say, I want a steak. What side dishes come with your steak? And they can rattle off the list of, well, you can have mashed potatoes, you can have a salad, you can have this or that or that. Right, and so all of those would become valid choices for you if you were ordering a steak. Right, so these questions that we're asking to our database, we can make them super specific, and when we make them super specific, we get a very limited set of information given back to us. And we can make them more vague, and when we make them more vague, we get a very broad set of information given back to us. It's all based on how we want to tailor the information, parse the data to give us value to help us tell the story that we need to tell, or to help us answer the questions that we need answered. And so just in general, there are methods for posing queries. We'll get more into that in the next module. All right, in this current module, we are just kind of dipping our toe into the water and getting introduced to these different concepts here. We can choose these sort of menu-based parameters, right? And we can kind of look for a query by example, and we can look at our query language, which is what we're using in this course, right? Our SQL, our structured query language. Right? There are different ways that we can kind of interface with the database. Right? Like if we were choosing by menu-based parameters, you might have seen some of those menus at the restaurant before where it's like, oh, you can get this meal, select one thing out of this column, select another thing out of this column, select another thing out of this column, and you get that meal for $9.99 or whatever, right? So we have these parameters that are already baked into our database, our choice structure. And so we're limited on what we can select from them. We know that we can select one from column A, one from column B, one from column C, or what have you. Query by example would be like, okay, you go to the restaurant, you got your menu there, you got pictures on your menu. And you say, oh, I want that. So you already have an existing example of some data that exists, and then they go back and they make you a version of that. Then the query language, as we've mentioned, is what we're doing here. The SQL, the structured query language, which is the most powerful method of querying a database. It gives you the most options. Right? In programming in general, we say, there's a lot of power that comes with options, having options and having flexibility. Right? We're able to sort of bend data, work with data to meet our own needs. We are not limited to previously chosen parameters or a set of pre-made examples. We have the option of being able to take everything on the menu and work with it a la carte, right? Which is, really what we're doing here. And so in order to do that, we have to use a programming language, and in doing so, you might expect this to be a lot like, just regular programming. But as it turns out, database queries, querying our databases for this sort of data is a little bit different than just regular programming that we're used to. Right, I got bad news for some of you math haters out there. Kind of turns out that this isn't really a programming course so much as it is like a qualitative algebra course. There's a lot of math that goes into this, but not math like we're thinking, 1 + 1 = 2, but logical math. We use the same sort of mathematic structures. Right? When we're writing a query, how we think about creating queries has a lot to do with, how we write equations and how we work with equations. We set up different pieces of data with different operators and modifiers to get an expected result. So things that we're working with have to be executed in a specific, particular, and logical order, right? We have to be doing things in a specific, standard order of operations. Things will be done the exact same way every single time. The only thing that will change is the logic behind how we build these structures in order to get the right data that we need. Right, so for example, if we were going to compare queries and equations, one of the big things that we could do here is we could say, okay, well, let's think about the Pythagorean theorem. Right, a squared plus b squared equals c squared. So we know that if we're dealing with the Pythagorean theorem, right, we're looking at any sort of right triangle, to get the length of the hypotenuse, I need to lower this mouse sensitivity a little bit. We need to take side 1 and square it, side 2 and square it, and then add them together, take the result, take the square root of the result, and then we will have the thing that we're missing here, right? So all we really want here is we want this bit of information. Right, we've got some data, we've got some raw values, right? We could say like x equals 3 and y equals 4. But in order to get the info, in order to answer that question, well, what is the value of c? How long is the hypotenuse of our right triangle? Well, we have to take these and we have to run them through a prescribed process, and we have a prescribed process here, which is our equation. So we take the first number, we square it. We take the second number, we square it. We add them together. We take the resulting number, we take the square root of it, and we get what we want. Now, if we were to compare that to say, select star from customers here, what do we want? Well, we already know what we want here. You might not know what we want yet, or you might not realize what we want yet. But we've got this bad boy here to tell us what we want. So when we look at select star or select whatever, our select statement is basically the result of our equation. So we can compare that almost directly to what we're getting as our result. Our select is what we're getting as our result. So when we're saying select star here, star in a database context, and especially in a SQL context, stands for everything, right? So we're going to select everything that meets the following parameters. So we get all the results that we can get from this table, this customers table. All right, so a squared plus b squared equals c squared. In this case, we're saying, our result here is a equals c squared. How do we get that result? We get that result by running it through this process. So in our second case here, we want everything from this certain process. So we want everything from our customers table. And so this will bring us back every single record in our customers table. So again, it's not exactly, quite the same as just simple math equations, right? We have a little more logic kind of going into this idea of, well, what does our equals equal? Because even if we say that our select part of our statement is our results, so we can kind of put it akin to what comes after our equal sign in a regular math equation. We're going to use the same select statement, but a lot of times what we're going to change is the process. What we're going to change is what comes after our from here. Because in this case, we're just using a specific table to pull everything from that table. But at the same time, what we're doing here is, we have other parameters, more parameters that we can be adding to this to modify our query, to change things up a little bit, so that when we get to the point where we're getting our information, we're getting what we want, we're getting what's valuable to us, we're getting the exact specific thing that we need. So if we were to look at that in a little more depth, we can see that all of our queries have some things in common. Yeah, it's okay, Matthew. I'm getting to an example here shortly. So all of our queries have something in common. So for now, we're starting slow and we're building. So everything that we want to get as much information as we can, we're going to select star or select asterisk, right? That's going to give us everything. And then from there, we can tell our database where we want to get that information from. So we basically just all we're really saying here is that we have a common equation structure from beginning to end. It's going to look kind of the same, just with some extra parameters here and there as we progress and as we learn more and more to be able to do that. So let's just do some stuff, right? Because that usually helps us a little bit more anyway. So this is our MySQL Workbench environment. I already have mine set up. I already have my tennis schema over here. So if you look at your left-hand panel here, this is your general server management. We can use this to connect to database servers on an actual server as well. Export, import, pull down, start, stop, different things, but we're just building the local database. And after you've followed the process that's in the module, right, in terms of taking our sample data and pulling it in, if we switch to our schemas tab, which is down here at the bottom of our navigator window, we can see that we have some different schemas here. Some of these are from just the general MySQL Workbench install. But the tennis one is our data set for it's our sample data set for our course. Right? So the first thing that I want to do, since I have multiple schemas here, is I need to tell MySQL Workbench which schema to use. So we're going to use tennis. Pretty easy query to just use tennis. Right, so that's going to tell my computer I'm using this particular schema out of all of these schemas. Now from here, I can click the lightning bolt or I can keep working. Doesn't really matter. Once I click the lightning bolt and I get a successful action here at the bottom, I can actually remove this query. So now it already knows I'm using tennis. Another query that I like to run kind of as we're getting started, just so I can gain an understanding of the database that we're working with here, is show tables. And so one of the things that we said previously is our database is a sequence of containers, right? Our database is a huge container. Inside of that, we have several smaller containers. Each of these smaller containers are called tables. And inside of those smaller containers, we have records, which is a single line. And then the data is each cell in that single line. So if we run show tables here, it should give us an output showing us our output here. And so these are all of the tables in our tennis schema. We see we have committee members, matches, penalties, players, and teams. So we can kind of think about that from the perspective of, okay, we have this big database. This big database is called tennis. Inside of this database, we have each of these different tables. Each of these different tables is named one of these items that we have here. So we have one called committee members, one called matches, one called penalties, one called players, and one called teams. And so it's each of these tables that contains our data. So we can actually run a query kind of similar to what we saw in our slide deck there, to pull data from one of these tables. Right, so let's say I wanted to see all of our players' information. So I don't need it to show tables anymore. I kind of know, okay, these are the names of my tables. Although these are the kind of queries that I will run when I'm starting to work with a new database, or when I am, sort of starting a new task to try to understand the database. One of the things that I might want to do is I might want to see all the information that's in a particular table, so I can understand, okay, this is the data that's in there. So if I were to do this and that, or that and this, or something else, right, I could get specific pieces of data out of that. All right, so let's write a query that will just get us everything back from our players table here. So here at the top, we will write select, and I will write my SQL keywords in all uppercase. You do not have to, right? All uppercase or all lowercase will work. I just like to have mine in all uppercase so they look different to you all. It will work either way. So I'm going to select asterisk. The asterisk is my wildcard selector. So I'm basically telling my waiter at my restaurant to bring me everything. Right? But I don't necessarily just want everything. I might just want everything from one part of the menu. Right? Like, bring me all the desserts that you've got. So we can say, bring me everything from players. Right, so select star from players. One of the things that I can do here as well, right, in my SQL Workbench, is I get these results tabs that open here at the bottom, so I can write multiple queries at one time. So maybe if I want to see, what kind of data is in the matches table as well, I can write one query that's select star from players, and another query that is select star from matches. And that's basically like I've told my waiter, you know what, bring me one of everything from the entree menu, bring me one of everything from the dessert menu. Run that. And there we have it. Now we can see at the bottom of our results grid here, we have two tabs. One is for players. One is for matches. And so right now, this doesn't mean a whole lot to us. Right? We're just kind of getting started setting up our environment. But the more that we kind of work with this, we'll get deeper into making comparisons and working with different things as as we progress, once we get into the next module, module 3. Because we can start to see things like, okay, the player number here in the matches table corresponds to the player number here in the players table. So if I wanted to know, for example, what we have here is match number, team number, player number, how many sets they won and how many sets they lost in a specific match. So if I wanted to get specifically how many sets were won by R. Parmenter, I can figure that out, right? Because I know, like, okay, if the last name's Parmenter, then I can find his player number. And then I can look up in this table that player number, and I can add together how many sets they won, and then I can get that, and I can do that all with one query, right? Just one statement can pull me back those specific numbers all added together. in fact, I just kind of pulled that statement just out of the air here. Yes. Yes. I just kind of pulled that statement out of the air here, Matthew, but yes, I will write that query. So let's do that. And a lot of these parts here won't make sense to you because we'll be learning them, right, as we progress. So, and I don't have this query pre-prepared, so we might have to do a little bit of editing with it. But I know, okay, I have a column here called 1. I know a column here called player number. So if I were to write this, I would write select sum 1 from matches, join, and let me keep my keywords consistent here, so we'll make this all uppercase. From matches, join players on players dot player number equals matches dot player number, where players dot what is it, name equals parmenter, something like that. Right, so we're just saying, take the sum of the amount that's 1 from matches, which is this window, join players. So we're joining those two tables together so we can see them at the same time. On their primary key here. So players.player number and matches.player number are the same thing. And then we just have our condition here, and fingers crossed, we get 8. So if we look here, we know player number 6 here is parmenter because our data sets here are small enough to where parmenter is player number 6. And we can go through here, we can count 3, 4, 5, 6, 7, 8. So we got the right results here. And we could do that for any player, right? Like we write the query once, and then we just substitute the player name. Right? For example, if we wanted to change this to be player number 104 here, or whomever from our other players list, right? 112. Yes, I could have done player number as well, right? So we can do players.player number equals player number equals some value, right? So if we know 112, then we can do that as well, right? And so that gives us 3. And so we know 112 here, 12, 11, which is, 2 plus 1 is 3. Absolutely. All right, and so with these small data sets here, which is why we use a small data set as we're getting started, it's something where we can easily go back and look and see if we got it right. Right? We get this instant result, but then also our data set is small enough to where we could go back into here and say, okay, I can find that player. That's 112. Okay, they got 2 there. They got 1 there. That's 3. So I know I'm right. And so if we get our practice in on small sets like this, when we have enormous data sets like you would encounter in, the real world, we can have more confidence in the queries that we write, that, we wrote the right thing and that we're getting the right answer, because, the results of these queries we can use them in different ways, right? We can just use them in relation to kind of what we're doing here, where we're just getting information pulled back to us based off of queries. But we could also use them on websites to populate different things and stuff like that, right? So the results of our query can be used for something else, and so if our query is off, then the other things that we do with them might be bad. Right, but where we're at here with our select sum from, we won't be like fully writing queries like this until like middle of November, right? So don't worry if you're not, understanding all the little pieces here. What I try to do in modules 3 and 4 is I basically just try to break down all the pieces that we need. Yeah. Whew. I try to break down all the pieces that we need. We do it little by little. We put them together. Right? So, it's not a huge deal now, right? Like, all we're doing right now is we're getting our environment set up, and like there's a query that you have to just kind of copy and paste into here just to see that you can run the query properly. But as we kind of get deeper into it, we can get to a point to where we can write some super complex queries that are giving us some really good information. But we'll keep going back to these queries here and ones like them time and time and time again. Especially as we're learning these things, one of the things that I suggest you all do is to run a query like this whenever you're starting to work with a table. Just so you have an understanding of what's in that table. Right? It's a lot easier to work with the table if you can actually see the table while you're working on it. See these column headings while you're working on it, instead of trying to keep it in your memory while you're doing it, right? So that's going to be part of the benefit to us here. We can do another example really quickly here, just so we can kind of show something else. Like a common one, I think one that we might be asked to do is to, find all the players that live in a specific town. Maybe I only want them by name. So maybe I want their initials and their name. So now that we're done with this query here, we can get rid of it. We're just going to be using the players table here. So we can have that. And I will go ahead and say, like, the way that I want you all to kind of turn in your assignments in this module, I ask for screenshots. And I also just like ask for text files, to where, you can take a text file. And with our queries here, we can just copy and paste our successful queries into a text file. And this data here, that's in our output, we can actually export that to a CSV file if we wanted to. So we can just kind of save that and copy and paste it into a text file. Or you can just copy and paste directly from here. You can select everything, like so, and copy. Just Control-C, Control-V into a text file. Right, but for another just example query here, let's say we want to get all the players' names that live in Stratford. Right, Stratford will be our example here. So now that we have these, we can get rid of those. So we're just working in the players table. So if I were just sitting down to try to answer this question, I would pull up my players table here, and I'd pull up all the information in my players table by selecting star from players. So star is everything from players everything from the players table. So now I can get all of the information from my players who live in Stratford. So select star from players where, let's see here, we can find that column here, town, where town equals Stratford. Like so. Right, really simple query. We've just built our formula here. We have what we want to get. We have where we want to get it from. And we have the parameters of how we want to select it. So we only want to select it if the town is Stratford. So when we run this, we get these results. And if we look in the town column here, every single one of them should have the same town listed. They're all from Stratford. But it could be that a lot of this information is just noise, right? And so if we're trying to take data and we're trying to turn it into information, oftentimes what we want to do is we want to get rid of the noise. So one of the things that we said we wanted here is we just wanted the name and initials. Right? And as we get even deeper, we'll talk about things like aliases, which will allow us to actually give a different name to our output than it has in the database, which is kind of interesting. But I said this star here, after select, is what I want to select. So if I just want initials and name, I can select initials. And let's do that all lowercase since it's not a common name. From players where town equals Stratford. Right, so I can use my successful query to build off on that for a new query. Now I'm just selecting different things out of it. Instead of selecting everything, I'm just selecting initials and name. And it will present them to me in the way that I've written the query here. So it'll give me their initials first, then their name second. When I execute that, we can see there are their initials and there are their names. We got rid of all that other noise that was in there. And I can assume that they're all from Stratford. One, because I based this query off of a past successful query. And two, it's what I wrote in my query. Right? But if I had a lot of questions about it, I could still compare that against our select star from players here. So I can see, okay, who do we got that lives in Stratford? Everett, Parmenter, Wise, Collins, or not Collins, Bishop, Brown and Hope, and Parmenter again. And so we can see all those names there. Everett, Parmenter, Wise, Bishop, Brown, Hope, and the other Parmenter. Right, so maybe you already see some things that could cause us to want to have more specific queries and cause us to want to have better information because, for example, R Parmenter and P Parmenter. Well, they both have the same last name, but they're two different people. So if I were trying to do something like that query that I wrote earlier, and I said, well, get me the total of wins for someone with the last name of Parmenter, which in this case is a little bit different because I don't think the other Parmenter, I don't think 100 is in that matches table, but we can select star for matches and figure it out. Player number, yeah, player number, we got lucky because player number 100 is not in here. But if player number 100 was in here, then we'd had to have changed our query just a little bit to be able to meet, to be more specific and get just the one person that we need, get their win count in there. But as we progress, we're just going to kind of do this like building blocks. We're just going to add little by little by little by little by little to it. Right, so we'll start off with the most super easy queries that anybody could ever do. And then by the time we're, you know, right around Thanksgiving time, right around the end of November, we'll be, using all sorts of queries to run our databases. Is it a rule of thumb to use a unique identifier to avoid mix-ups? Yes, it is. So in this case, we're using our player number as a unique identifier. Right? In our players table here, our player number is what we call our PK, or primary key. So in this instance, we have a unique identifier for each of these players here. So ideally, we would use our player number to identify who we were going to get between different tables. But we might have to figure out what that player number is, right? And so we might have to query some of the other things that we know about that individual to be able to pull back their player number so we could do something else with the player number in other tables. But yeah, that's exactly why we use a primary key or unique identifier, because when I look over here, this player number here, in this table, we call it a foreign key because it's relating to another table. The primary key in this table is the match number. It's the unique identifier for each row in this table. Our player number here is a foreign key because it relates to the unique identifier or primary key in our players table. And so when we create relationships between tables in our relational database, we need some point of relationship for our tables to be able to know one another. Right? And so in this case, we're essentially saying, when we want to query in between these two tables, that this player number here is the same as this player number here, right? Which is that whole big join thing. We can have a look at that again really quickly before we go here. Right, so if I wanted to get all the unique players, right, which we can do that as well, I can select select distinct well, I wouldn't even really need to do that, right? These more advanced queries I'm just kind of thinking of off the top of my head right now. So what I want to do is I'd want to select name from players, join matches, on, right? My on here is that relational point on players.player number is the same as or equal to matches.player number. So that right there tells it that this same column of information equates to this column of information. So if I see 2 over here, I'm talking about R. Everett. Where do I want in here? I might want in. Yeah, this one actually I think is a little more complex than I want to write here, but we can go ahead and push that forward. Where matches dot player number in select matches dot player or select distinct matches dot player number from matches. I think that might be pretty close to what I want here. Let's check it out. Okay, not quite. Probably should have just added a select distinct here, and that would give it to us. There we go. So I'm able to, take these match numbers. This gives me a list of unique match numbers. This is the relational point. This gives me unique names from that list. So it gives me the names of all the players that have had matches in this table. Right, again, that's something that'll come down the line. For now, again, we just want to get our environment up and running. We want to be able to get our data set loaded. We want to know how to add our queries, click our lightning bolt, and get our results. So these super complicated, crazy queries like we have here, not going to worry about them right now. But we've basically hit our hour mark here, so we'll go ahead and stop here. If anybody's watching live's got any further questions, be glad to take those now. I'll hang out in the chat for just a few minutes while so you can get those questions into me. If you're watching the recording sometime later and you have questions while you're watching the recording, please feel free to send me an email. But that's all that I have for you for today. Thanks for watching. We'll see you next time.
Future.